Hey, welcome to my session where we're going to talk about how my company Chegg unlocked innovation without breaking the bank. So it's a story about our journey into the cloud and beyond. So my name's Steve Evans. I'm the Vice President of Engineering Services at a company called Chegg. I'll talk about it in a second. And then later on, my friend Zev's going to be joining us. He's from a new acquisition from NetApp called Spot, and he'll talk a bit about how they helped us in our journey. So if you're not familiar with Chegg, that means you're either not old enough to have a kid in college or you're too old to have been in college when we existed. Basically, we help students, college students specifically, through their journey from textbook rentals to various study aids like Chegg Study, Chegg Writing Tools, etc. So about 5 or 6 years ago, um, we decided we need to lay out a set of priorities for the technology team at Chegg. So we set some goals. So first of all, we decided we need to improve our time to market, super common, right? We need to increase our quality of service, and we need to decrease our operating costs. So bit of a trifecta there, right? So why? Well, it's good for our students because they get a better product by faster time to market. It's good for our employees, it gives them a better career. And it's good for our business because it provides them better financials, not only on the operating cost side, but presumably through better product, better revenue. So rewinding in time, at the time we were in a data center, typical colo setup. We'd buy servers, capitalize them, all that kind of stuff. And so we got a forklift, loaded everything onto a FedEx plane, and shipped it all off to the cloud. And that is exactly how cloud migrations work. So mission accomplished, right? Everything's great now. We're running in the cloud. Everything's perfect. It's cheaper, runs better, deploy it faster, etc. So before we threw the party, we thought, let's go back and let's check those goals. So did we improve time to market? No. Nothing about moving to the cloud was going to make us develop features and products faster. Did we increase our quality of service? No. In fact, you take a application stack designed to run in a very static data center environment and you move it into the very dynamic world of the cloud, you're actually going to see quality of service decrease. And then finally, our operating costs increase because we're paying that cloud tax. We're paying for the flexibility that the cloud gives us, but since our application architecture didn't support it, we weren't taking advantage of the flexibility that the cloud provides us. So let's talk about how do you improve time to market. So if we walk through how you add functionality to an application, we decide, okay, we're going to build this new application, this new feature inside of this application, whatever the case may be. That application team goes and works with the operations team and says, we need some servers to host this new application. And then we deploy that application to those new servers, right? So that's the right, quote unquote, right way to do it. But we missed a few steps, right? So we got to go convince operations to build those new servers. I know this is hard for some people to believe, but ops folks aren't just sitting around waiting for work to do, right? They've got a lot going on and they got to carve out time to do that work to build the new infrastructure for that new application. Invariably, you run into there's a reason it works on my machine is such a cliche, right? So you're going to spend cycles debugging those missing dependencies, those missing whatever the case may be, but you're going to spend time just making it work. And then finally, after all of that, you're just going to hope and pray that you did your capacity planning correctly. And considering you're deploying something new, you didn't. And so invariably, you're going to run into pain points there. So what's the easier way? Add functionality to an existing application, redeploy it. Does it give us the granular scaling we want? No. Does it give us the flexibility in our development process down the road? No. But it makes the product manager happy in the short term, right? So what do you think happens most of the time? And then on top of that, we're paying that cloud tax. So I've done a way oversimplified example here. But let's just say to run our application, we need at the baseline, we need 10 M52XLs. This is an AWS example, but you can copy this over to any environment, any cloud you want. So I need 10, 12 months of the year, and the other 10, 6 months of the year because I have seasonality. Okay. So out of the box, I pay the on-demand price. That's $290 per server per month. That comes out to, and then obviously I only have to pay for 10 of those servers half the time, right? Yearly price works out to $52,000 a year. Okay. So you say, well, that's more. That's more than I used to be paying. So what can I do about that? Well, you can move to what's called a no upfront convertible reserved instance. So you can say, I'm going to run these 10 instances for the next 12 months. I'm going to lock myself in. And so instead, I'm going to pay $216 a month and then still pay the on-demand price, that $290 for the 6 months. That pulls me down to $43,000. You're correct. That is less than $52,000. Still a lot of money. Now, keep in mind, we're talking about one server farm here with one level of complexity. Multiply this by tens or hundreds of different scenarios, right? That we've got to think about all this, manage it all really well. The last one is I could say, okay, Amazon, I will pay for these 10 servers all up front. I will give you the cash today. They'll only charge me $164 a month. So 164 times 12, that goes from my bank account to theirs, which is good because I know Jeff Bezos is struggling. And then I still pay my $290 a month for those other 6 months. And voila, I'm down to $37,000. Now let's hope I actually still want those 10 servers in 10 months. Let's hope I don't try to do something else. And let's keep in mind, I've got to do this for every scenario I'm in. And there's a bunch of other options here. We got 3-year upfront. We've got, savings plans, compute plans, etc. And so at this point in time, we said, I'm out. I've got better things to do with my time. I want to focus on Chegg's mission, not, managing RIs. Who can do this for us? And so that's where we turn to Spot by NetApp with their eco product that manages all this for us. Zev, you want to talk to them a bit about this?
I've been waiting for this moment, Steve, so for sure. As Steve explained, most AWS customers get to a point where running their EC2 instances with on-demand pricing becomes prohibitively expensive. That's when they look at AWS's reserved instances and savings plans, which can offer up to 72% cost reduction in comparison to on-demand pricing. However, to get this pricing, you need to commit to either a 1 or 3-year term, and this is where things get tricky. Capacity planning in large, complex, dynamic environments, typical for enterprises, is hard to get right. Long-term financial commitment can easily go sideways. And when things do go sideways, which happens on more than just an occasion, offloading these underutilized or unused reservations in Amazon's secondary marketplace takes a lot of time, something you don't want to do. If you bought savings plans or convertible RIs, these can't even be resold in the Amazon marketplace if you need to get rid of them. Another issue that comes up is employee churn. It happens. You have someone who's responsible for buying reservations. They leave the company. Now you don't even know what they bought those reservations for, if the projects they were bought for even exist. Major visibility issue. Another issue that comes up is timing. You have a plan to go and take all of your instances that you know are too large for their workload and downsize them. You're going to do this next month, the month after, maybe 6 months, maybe a year, whenever. It's going to happen. And you want to wait, and it makes sense. You want to only buy reservations once you've right-sized all of your instances and everything matches perfectly. But in the meantime, you're wasting a lot of money. Another issue more on the financial side of things is, to get the best deals, you actually have to put money down up front. You have to, not just a commitment, but you actually have to pay up front for some of these reservations. And this can create a cash flow issue. You may not have the money available, or you may not want to spend that money. All these are legitimate concerns, legitimate challenges, but at the end of the day, reserved instances, if handled properly, can deliver major savings for all of these scenarios. And this is exactly where Eco comes into the picture. So Eco analyzes your historical and planned cloud consumption and builds out accurate projections without you needing to rely on cumbersome spreadsheets and have multiple teams spending hours and maybe even days or weeks trying to figure out if reserved instances are worth it for this team or for that project. It's all done automatically. On the right side of the slide, you can see a typical eco-built reserved capacity portfolio. Now, these are fully customizable based on your strategies and on all your needs, but the typical aim is to have it as flexible as possible with the most savings as possible. So Eco will go and seek out secondhand reservations on the Amazon Marketplace. These typically will have a shorter term, 3 to 6 months. For a 3-year reservation, which offers the most savings, we'll try to get those for a year and a half. Bottom line is shorter terms with maximum savings, so you get all of that cost benefit without the long-term lock-in. Of course, when it's warranted and typically in smaller overall percentages, Eco will buy convertible RIs and savings plans, which can't be sold but can offer higher savings. Now, in the event that things change, and as 2020 has definitely shown, Forrest Gump's mama was right. Life is like a box of chocolates. You never know what you're going to get. So you had this project, you thought it was going to last forever, but it ended 6 months early. What are you going to do now? So Eco will go and take these unused reservations and sell them for you. Now, Eco has a built-in network effect. We have over 1,500 customers using reservations. So our capability, Eco's capability for finding buyers for your unused reservations is tremendous, making it very easy to offload anything that's not being utilized, that's basically wasting your money, and make sure that you have a lean and mean RI portfolio. Now, of course, you can do all this manually on your own. But as Steve pointed out, his mandate is to drive innovation, not to spend his time and his team's time on buying and planning and selling reserve capacity. So that's really my little overview of Eco. Back to you, Steve.
Thanks, Zev. Now, I had some really smart people on my team, still do, and they were doing that for me. The reality is, I was able to offload that to Eco. They were able to actually maintain my costs and even improve them with taking a bunch of workload off. And it gave me a lot more flexibility through the much more robust plan. I think of it as buying individual stocks myself, as opposed to, having a money manager that can really see the whole market and think about my money in a much smarter way. So, what else issues do we have post forklift? Well, so we can scale now. I just talked about, okay, we'll have these 10 servers for 6 months, but it's really, you know, not fine tuned scaling. So in this case, I've got a bunch of over capacity. And so I'm paying for that excess capacity. Now, true, I was doing the same thing in the data center, but at least I was capitalizing it. The per hour costs are actually lower. And so it wasn't as painful. And then finally, quality of service. So while I have that ability to scale, I better hope I get it right. Um, the seasonality of Chegg's business can be very. We have some very big spikes at certain times of the year. Think about when students go back to school, and all of a sudden everyone needs a textbook at the same time. And so, keeping in mind, we're having to scale these across dozens of server farms. Not just we got to get it right once, and invariably we'd always miss something. And so, what happens is our demand outstrips our capacity somewhere at some time, and then we're potentially losing orders, which means not only did we miss out on that revenue, but we didn't serve the student like our mission, drives us to. And, thinking about quality of service. So post forklift, nothing about now running in the cloud has helped us in what I think the fundamental issue is, which is the lack of feedback loops. So in a traditional SDLC, you have development that builds and potentially tests the application. And then you have ops teams that deploys and operates it. Well, the developers, they become experts at building and even potentially running that application in a test environment. But they get little feedback, if any, about how the deployment process went or how it works in the real world under load. Because when something goes wrong on the site, the ops team runs to the rescue. Now, the absolute best ops people are working hand in hand with the dev people, But at the end of the day, it's still, they're telling a story about what happened as opposed to the developers living it and getting to understand what happens when my application's under load, when something, a server fails and the traffic keeps coming. And so we still had these broken feedback loops. So we took a step back as a leadership team and we said, okay, this isn't this didn't solve all our problems. And obviously we knew it wouldn't solve all our problems. So we changed the question a bit and we said, what are insert type of team good at? And how can we get them to do more of that? How can I get product engineering teams to build more product? And how can I get infrastructure teams to focus more on robust, scalable infrastructure and everything in between? So a bit of an aside for a second, but one major thing we invested in was managed services. So again, we're an AWS shop, but this applies to many different clouds, all clouds. And the example I like to use is RDS. My understanding is the RDS team at AWS is larger than Chegg Incorporated. So that means it doesn't matter how much I care about relational database, AWS is going to do a better job than my teams can. And so I offload that responsibility to AWS and I let them be my database expert, or at least my relational database experts. And I allow my teams to focus on more Chegg value specific add-ons. That's really helped us improve our time to market as we focus in on what matters and we let the RDS team solve those generic problems. It's increased our quality of service because they're operating at scale and they've seen it all, right? And we've seen none of it. And actually decreasing our operating costs as we really hone in on running optimized MySQL Postgres compute. As we really focus in on doing the right things there, we've actually, and along with a really strong RI strategy, we actually been able to decrease the operating costs of our data tier. The other thing we really invested in this time period was containerization. So thinking about how we broke down the application and really focused in on providing, moving to a microservice containerized model, allowed us to improve time of market because we created really clear line of responsibilities. The host, infrastructure team, the container, application team. We enabled self-service creation of new services. So if you want to run a containerized service, you can do it all on your own. You don't have to get anyone's permission. You don't have to go carve out time from another team. You can just do it in a self-service manner. With containerization, when I think of containerization, I really think of auto healing and I really think of next auto scaling, which increases my quality, also decreases my operating costs. So I can scale up and down as our students' demands change. But we can also auto heal. If a container gets unhealthy, it just gets removed from service and a new one, an additional one gets launched in its place. Now keep in mind, this is happening across hundreds of microservices now. So as one service needs more capacity and another one needs less, those fine-tuned adjustments are happening in real time, and not something that we have to plan ahead for. We're thinking about more on the macro level now. So, thinking about how containers, they scale minute by minute. As those demands change, they can scale up, they can scale down, and my compute capacity can scale up and down with it. That not only improves my quality, it's decreasing my compute costs. And then thinking about that, well, what's the right way to launch new functionality? Now it's create a new repo, write your Docker file, build, deploy. There's, literally, I'm responsible for infrastructure at Chegg. No one checks with me before deploying a new service because we've created a platform on which these teams can self-service and deploy their own stuff in a supported, guardrailed, scalable way without having to get an infrastructure team involved, which is a huge win. When we launched this capability, we saw the number of services we were running in production just balloon. Now, some of this was probably, oh, I got a cool new toy, let's go play with it. But the reality is, I think what you really see here more so is the pent-up demand that our engineering teams had. They wanted to do these microservices. They wanted to break down their applications for monoliths. And by getting infrastructure and operations teams out of the way, we allowed these teams to really thrive. So you can see there where that's about when self-service came into play, and you just see it shoot through the roof. The other thing we did at the same time is we said, instead of, hey, this type of team builds stuff and this type of team operates stuff, we just moved away from that model and we said, you build it, you deploy it, you operate it. And so now when team A's application in production fails, they're the one getting paged about it. Guess who's the most motivated to fix that problem and make sure it never happens again? It's just we've just seen huge improvements in the quality of the services we're providing as we handed over that power and gave that responsibility. It's allowed product engineering teams to really focus on providing great product. It's allowed infrastructure teams to really focus on no longer thinking about how do I scale up a couple instances for this particular application, but how do I provide robust compute, robust data tier for a large, as a platform, not as individual solutions. Let's go back to our goals: post-containerization and decentralization. Did we improve our time to market? Yeah, absolutely. So now teams can build and deploy new services, low friction, remove the barriers, let them do the right thing. Did we increase the quality of service? We fixed our feedback loops. Services auto heal, auto scale. The technology supports that as is. So huge increase in quality of service. So after taking all these applications and just ballooning the number we had, providing the compute for all these additional services, did we decrease our operating costs? Of course not. So as I was saying, significant increase in the number of services we were running. And we saw our bill rise with that, right? It wasn't a one-to-one mapping, but it wasn't at a healthy rate. But one of the things we realize is another upside of containerization is it's a really hard to do containerization unless it's stateless. And so by fixing the ability to auto heal and auto scale, we also fixed any non-stateless applications we had and really moved away from that model into a much more cloud-friendly model. At which point we said, well, what can we do about our compute costs? So again, I want to turn it over to Zev, and I want him to talk to us a bit about their Ocean product and how it enabled us to run all this compute on AWS Spot instances.
Thanks, Steve. This is actually a huge topic that I'm going to try and compress into 2 slides. So here goes. As Steve mentioned, Chegg was moving towards stateless applications, and as that happened, the possibility of using EC2 Spot instances became more realistic, but not completely. Now, just for some very brief background on Spot instances, these essentially represent Amazon's spare compute capacity. Every public cloud provider needs to have spare capacity just in case there's a surge in demand. Take, for example, what happened to Zoom during COVID-19, which is still going on. They went from 10 million daily users to over 300 million daily users in a very short period. And Zoom happens to run on, at least partially, on AWS. So AWS always needs to be prepared for surges in demand, and that's why they have this spare capacity, also known as spot instances. Now, for the remainder of the time, when there are no surges, you have a lot of idle compute capacity sitting around, and to offset the loss, the financial loss of these idle resources, AWS will go and offer these at rock bottom prices, up to 90% less than on-demand pricing, to kind of lure customers to come in and use it. Now, the caveat, the drawback, the major issue with spot instances is that Amazon can pull them away, can take them back at any given point in time. If there's demand for on-demand users need those instances, or reserved instance customers need those instances, Amazon will take away those spot instances from you and give them to on-demand or reserved capacity usage. And this is with just a 2-minute warning. So even for fault-tolerant stateless applications, these sudden potential mass interruptions are simply not acceptable. So they're very attractive in terms of cost, especially for stateless workloads, but still for mission-critical applications and processes, this is really, really tricky. So I kind of covered there a little bit about the benefits of spot instances, as well as the first challenge. Completely unrelated to spot instances, this could be for any type, whether you're running on demand or even reserved. Um, there's the issue of scaling. So when you're running your containerized workloads, the traditional auto scaling, they're looking pretty much at the overall utilization of your cluster. They're not looking at the individual nodes or instances in relation to the container requirements. So you may have some containers coming on that require X amount of CPU memory, and the traditional autoscaler will look at the aggregate availability within your cluster and say, okay, there's enough, we don't need to do anything. But the reality is that containers are limited to this one constraint that they need to run entirely, a container needs to run entirely on a single instance or node. And if that single instance or node doesn't have sufficient CPU or memory, that container will not run. And the autoscalers don't necessarily pick up on that traditionally. And what results from that is you could have a lot of pending workloads, a lot of pending containerized applications that don't run because the scaling isn't reacting the way it should. So that's one major issue. That's really a mismatch between the container requirements and the underlying infrastructure scaling. Two other challenges that often come up for containerized workloads are right sizing and spend visibility. Many companies are using t-shirt sizing for their engineering teams. You have small, you can spin up a small, medium, large, or extra large. And of course, everyone wants to err on the side of caution, and they're going to spin up machines that are way too big than what they actually need, and you end up with a lot of underutilized resources. Definitely not efficient. Another issue that comes up is that containerization, while allowing you to really get a lot more in theory out of your underlying infrastructure, you have many more applications, many more containers running on a single instance. It actually confuses things and makes things very difficult in terms of cost allocation and understanding, who is really using this particular instance or group of instances, because you're going to have a lot of teams, a lot of projects, all when you're using containers that are all using single sets of resources, making cost visibility a big mess. And with all these different challenges, this is exactly where Ocean by Spot comes into the picture. So over here, you can see on the right hand side, it's a kind of simplified diagram of what's going on, and I'm really going to try to pack it all in here. It doesn't really matter whether you're using EKS, ECS, GKE even, other Kubernetes orchestration platforms. What Ocean does is it eliminates the nitty-gritty details of server management. It always supports your container workload requirements with the appropriate underlying compute infrastructure. It will spin up nodes of varying types and sizes to match your pods or tasks requirements. It does a lot of intelligent bin packing to eliminate any excess compute capacity, making sure everything's fitting in as tightly as possible, maximizing each and every node. And all at the same time, you still have the capability to configure custom headroom or spare capacity within your cluster, so there are never any pending pods or tasks for very important workloads. Now, along the way, Ocean is constantly assessing your cluster's utilization, the resource utilization, and providing you with recommendations if you are able to downsize your resources, the underlying nodes, to create even greater efficiency. That can all be automated as well. And of course, last but not least, Ocean does all of this running your containers on Spot instances. We have predictive algorithms which are able to detect when there are going to be interruptions in the spot market, when AWS is going to pull back those Spot instances, take them away from you. We can predict that in advance and then gracefully drain your workloads and in advance spinning up new nodes, new instances for your workloads to run on, so you never suffer any interruptions. And of course, this helps you to achieve tremendous cost savings. Again, it can be anywhere up to 90%. In the case of Chegg, they're seeing on average around 70% cost savings. And all this is with an SLA for high availability. If you happen to be using reserved instances, Chegg is as well. They're using Eco for that in general. But Ocean is integrated with that. And before Ocean will spin up spot instances, it will look to see if you have any available reserved instances and will use those before. So you always are getting optimized utilization of all your resources. In the event that there are no spot instances available, uh, Ocean will handle a fallback to an automated fallback to on demand. So your workloads will always be running. And then as soon as there are spot instances available, we'll automatically revert back to spot instances. So that way you're getting the cost benefit without you having to manage anything. Um, as I mentioned before, on the financial side of things, you have your controller, you have your accounting team. They want to know who's using what. So Ocean also provides cloud native visibility, allowing you to drill down into your cluster cost by things like, for example, namespaces or labels, annotations, all in Kubernetes, and their counterparts for ECS, for example. So you can really see exactly what each and every team and project is spending in the cloud. So this is a more complex technology and a much broader solution. But I hope that we're able to cover it. And definitely, as Steve can testify, at Chegg, they're able to use Spot and Ocean to really drive their costs down, even for their mission critical production environments, without any impact at all on performance. So back to you, Steve.
Thanks, Zev. So I just wanted to give a real world example here. So we had one cluster. This is just one of our clusters for 1 month. We have dozens of clusters for dev, test, prod, different environments, different accounts, different product business units, etc. So this is just one cluster for 1 month. It's not our biggest one, but it's also not our smallest. So without Spot, we would have ran this cluster would have ran that week for about 114K. With Spot, it was about 39K. That's a $74,000, almost $75,000 savings. That's one cluster in 1 month. This has fundamentally changed the way we can think about how to operate our compute and do it in a way that makes sense for quality of service, time to market, and move away from thinking about compute costs. It has the capability to fall back to on-demand instances, but it's a very rare instance where I ever see that. So these kinds of savings are very, very reliable and allows us to really grow our business in a way that would be, a little harder to do without Spot in the picture. We'd still be growing like crazy, but we'd be struggling to find ways to maintain our OpEx costs. So Spot's been a huge win for us. Going back to that concept of services were increasing, costs were increasing. The reality has been much closer to this purple line, which is our compute costs have been just slammed to the ground and really flattened out because we're paying pennies on the dollar for these instances on the spot market. So going back to our goals, improve time to market, increase quality of service. We already talked about that. Now we decreased our operating costs thanks to Spot coming to the rescue. Thanks for joining us. You can find me online at www.sevans.info. That will take you to my LinkedIn page, or you can connect with me on LinkedIn at the Loud Steve. Also later this week, or maybe it's earlier this week, I really don't know. I was part of a roundtable called Ready Set Cloud Cost Optimization. You can find that on the Insights agenda. Zev would like me to share with you that to connect with Spot by NetApp, there's a couple more sessions taking place at Insights, so you can learn more about the details of how we, not only Chegg, but how you could leverage the services provided by Spot. And then a couple links here that take you to free trials to get started with Ocean and Eco and to learn more.